I'd like to go through basically civil environmental engineering with you in terms of basically the school and the opportunities that exist in civil environmental engineering. I'd like to also go through basically a little bit of an introduction in terms of the course structures that exist. And also, I would like to also give you some information on basically pathways and other degree options that we actually have as part of the School of Civil Environmental Engineering within, obviously, the Faculty of Engineering and Information Technology at UTS. So just starting a little bit about what civil engineering is all about. So civil engineers basically design, build, operate, and maintain basically infrastructure, and they also are involved in overseeing projects which may involve demolition. And some of the more specific areas that you actually see within professional practice and the workplace, when we're talking about infrastructure, we're talking about buildings, roads and bridges. Very large road networks are arterial ways that we can make connections between communities. Bridges are there obviously to go over water, or maybe even something that's not there is tunnels, which is becoming increasingly popular. And we actually have very large buildings which accommodate commercial sector, and also we actually have residential buildings as well. But civil engineering itself is not just strictly those areas. It also involves understanding a little bit about dams and waterways and water supplies and pipelines, and also sewage systems, basically through hydraulics and hydrology. And when we talk about sort of international type connections, we also have to consider things like harbors for basically shipping, transportation, airports, railways, which can make connection between countries and communities. And we have underground mining operations, and tunneling's mentioned there as such in terms of the areas that I mentioned before. When we are actually talking about environmental engineering actually looks at the environment and the impacts, obviously, that a project may have on environmental conditions such as air, water, soil, and noise levels within the vicinity. And some of the particular requirements of an environmental engineer are project design, construction and operation, and to be able to understand how to actually mitigate basically any environmental impact in terms of a project. And so this may actually involve examining past activities by actually understanding some previous problems and challenges that communities have had to face. And you're dealing with a lot of stakeholders in this group. You may have to clear some contaminated land, industrial sites. You may actually be called out to respond to accidents and environmental disasters, for example, oil spills. And in this process, you need to sort of put forward a plan and design implementation and suggest equipment in order to safely dispose and treat, obviously, that waste material. In environmental engineering as well, and in recent times, we are also exploring basically alternative energy sources. So to be a civil or an environmental engineer, what are some of the particular skills or competencies that it is that you require? Well, you require professional skills to be able to undertake problem solving. A lot of civil engineering jobs, environmental engineering jobs are going to ask you to be proficient at tackling a problem. So you split up the problem into smaller steps and you work on those progressively. You may be within a team environment, you come together, you debrief, and you can resolve, obviously, that particular challenge. And in doing this, we need to be very mindful of specific budget and time frame requirements. So we need to project manage and we need to time manage, and in terms of economics, be very careful that we're kept within, obviously, our budget constraints. So when we explore civil engineering and environmental engineering, there is an understanding of maths, and particularly calculus, trigonometry, and other maths topics to be able to analyze, design, and troubleshoot a problem. As I said, if you fragment it down to a smaller component, it's easier to deal with. And when you're dealing in the community with engineers, stakeholders, where your stakeholders could be your clients, they could be the community, they could be a supplier, they could be a project management team, and you're the interface. It's very important to actually have the right form of communication skills and to demonstrate leadership. A lot of engineers, civil engineers, environmental engineers are actually project managers or site managers. That's often one of the main career choices that they take on. And when you demonstrate some leadership skills in that process, you're also using critical thinking skills and project management skills. And just very briefly, critical thinking actually requires you to go away and do your own studies and to have a look at literature and some past studies. These could actually be even practical studies within the firm that you work for, the organization or the company. And you can actually bring out some of those particular findings and share them accordingly as part of your critical thinking strategies. So when people talk about civil and environmental engineering, it's often a little bit complex to actually understand how broad the area is. And quite often, it's a combination of a lot of these areas that actually overlap. You can see there that we've got construction. So you may be on a site, you may actually be the project manager for a site. You've got environmental engineering, which I've briefed on previously. We've got geotechnical aspects, which actually look at subterranean aspects of engineering. My area of specialty is materials. So construction materials, very important, particularly concrete and steel, and also some timber constructions, very important. Structural requirements require you to be able to go through and design and model behaviors. You may be involved in transportation, where you're actually looking at artificial intelligence to be able to give you some indication of predictive measures of how transportation happens. Particularly, I'm sure a lot of you have used obviously rail and bus, and you will notice that there are timetables, there are planned stages to make sure that commuters can reach from location A to B in a timely manner. And this involves also urban planning. And when we talk about transportation as well, we also have the civil engineering side in terms of road engineering practice and being able to understand some of those particular engineering structures and infrastructures. And finally, we've got water resources, where we need to understand flood and drought behavior and be able to predict and estimate basically flooding requirements, floodplain risk requirements around communities, precincts, and obviously commercial sectors. So some of the career opportunities around civil engineering and environmental engineering. You could be involved in a catchment management system where you actually are looking at reservoir systems, how well basically rainfall is captured and harnessing that rainfall and using it for communities and future generations. You could be involved in a very large construction project where you may actually be leading a team of engineers, or you may actually be seeing the whole entire construction phase by liaising with the clients and the designers in that process, the suppliers and the project managers. You may be involved in conservation and natural resource management, which is a very important issue in Australia and around the world, where we're actually trying to harvest basically energy and use alternative sources to generate energy, which are more environmentally friendly and with a lower carbon footprint. We've got the mention of energy here, particularly energy around solar, wind power, methane gases, around bioenergies. I think these are very important areas, but the most important thing to realize is that there are infrastructure and particularly storage systems that we need to consider, and we need to be able to design plants around this as well, manufacturing plants that produce these energies as such, production plants. We've got the mining industry, which is all underground, and in the mining industry, some examples include, for example, tunneling arrangements, being able to reinforce those tunneling arrangements, making sure those shafts can connect and are structurally stable. There's resource planning and management around making connections between communities and being able to have resources and all the various facilities and services located in very close proximity to those particular resources. We have oil and gas, exploration and mining. Again, we've got particular structures that are made around obviously these particular requirements. A very important area is water and waste management and preventing things going into landfill. And there's also government jobs, local, state, federal, and international legislative type areas where we can involve ourselves in, particularly in terms of organisations. So just to share some particular areas with you, you can see here, there are some really cool illustrations here of various different areas that I mentioned. We've got dam structures here, waterways, we've got maybe even hydropower. We've got obviously industry in the middle here where we need to contain obviously pollution measures. We've got this really neat new type of design around basically a stadium construction. You can see the road here making a connection between communities. All of this is basically civil and environmental engineering combined. Down the bottom here, we've got an oil rig, so the platform, the concrete that supports obviously this, the buoyancy, the cranes, the design around load handling and being able to lift things and items out of the water, pump obviously petroleum and process it. All of these are very important. A breakwall structure here in the middle down the bottom, separating obviously tidal flow, making sure that basically communities are protected and harbours, etc. And here you see a really nice shot showing you an environmental aspect, a coastal type plant that does treatment. In the background here, you can see another plant. In the foreground here, you can see obviously waterways separated. So basically civil environmental engineering really gives you a really good dimensional aspect to future career opportunities. So here at UTS and within the Faculty of Engineering and Information Technology, within the School of Civil Environmental Engineering, we actually have basically 3 types of degrees that fall under a civil engineering major with core specialisations in the area of civil general, civil construction, and civil structures. I'll explain a little bit more about these now. So basically civil general gives you basically that requirement where you've had that experience in multiple areas of civil engineering and you've dabbled also in environmental engineering, and you come out with obviously a more general understanding of civil environmental engineering. Civil construction actually focuses a little bit away and goes into the area of construction, particularly around project management and site management. So you start to sort of do a little bit more of those social subjects where you make a connection with the team of professionals and you lead that team and you understand construction technologies. And civil structures actually focuses on basically understanding a little bit about design and modelling aspects where you actually may work for a large firm and you're a principal design engineer that's responsible for overseeing obviously a tender process, and you need to bring in obviously some design requirements to foresee obviously that tender go through for obviously having a chance of being awarded to obviously that firm. We also have the civil environmental major, and this particular program, which I'll show you on the next slide or so, is actually a combination of civil and environmental engineering subjects. It actually has some civil engineering in there, and it's actually got some environmental engineering subjects around the periphery to actually help your understanding of civil engineering. So just to go through some of these a little bit more for you in depth, this is what a typical course looks like at UTS. So you have 5 years. You've got year 1, year 2, year 3, year 4, and year 5. This is the one around the major in civil engineering with basically the specialisations in the 3 different areas that I mentioned. So you've got civil engineering, you've got basically civil construction, and you've got civil structures. And just to explain a little bit here about the flexibility we have in our programs here at UTS, which is really great because you can transfer in and out of different programs, even if they're not within the School of Civil Environmental Engineering. So all these subjects that you see here highlighted in red are common for every single engineer in the faculty. So they all do these subjects. And much the same, they do these 2 blue subjects here as well. So there's a lot of commonality between obviously the engineering degrees. When we look at the School of Civil Environmental Engineering, you can see there are more subjects here, these white highlighted subjects here, which are actually core to the school. And so these subjects up here earlier on are something that basically all civil engineers and environmental engineers do as part of their requirements for the particular degree in civil engineering. When you move over to basically this second block here, you start to get involved in the specialisation streams that I mentioned. There are 6 subjects in the specialisation stream, and they're basically 6 credit points each, and students typically do per semester 4 subjects. That gives you a 24 credit point load. You can see there are some other subjects here that are a little bit more advanced around civil engineering, for example, soil behaviour, geotechnical engineering, hydraulics and hydrology. And then when you move over into this third block here, you see the specialisation stream continuing, and you've got this option of selecting 4 electives. Now, these electives can be at your choice. They can be from the School of Civil Environmental Engineering, they can be from other schools within the Faculty of Engineering and Information Technology, they can even be offerings from other faculties. And this allows you to basically create your own little unique expertise to be a little bit different to your peers. So when you go out for a job, some of you may actually elect to go into, say, for example, commercial law and patent law. So you may do some law subjects here around basically patenting engineering innovation. Some of you may actually elect to do postgraduate subjects from the School of Civil Environmental Engineering in the area of structural engineering and design. So there's some examples of basically how electives actually shape a little bit of a different completion with some specialisation specifically in those areas. Now, importantly, when we look at basically block 1, block 2, and block 3, this is basically understanding the fundamentals behind theories within civil environmental engineering, and particularly in this case, civil engineering. Over here in block 2, you start to get involved with applications. So once you've learnt the theories here, you can start applying them in block 2. And this is what we call our professional block, where you go out into industry, which I'll explain very shortly by these dark coloured blocks here in between. And you come back and you put that into use to basically prepare a final year project, which is the engineering capstone experience, which starts basically in autumn and finishes in spring, but there's flexibility to start these programs in spring and also in summer. So just coming back to give you a little bit of an understanding of basically these 2 blocks here, these are your internships. And this is what UTS sort of prides itself on in terms of that professional workplace experience, which is a very important part. Quite often students go out and do this component, they come back with a different mindset and they want to change specialisation, or they may even want to change the actual engineering degree that they're wanting to do. These particular experiences here are a 24 credit point experience, very similar to what we have here with 4 subjects, each with 6 credit points. And not only do you go through one experience, you go through a second experience. So just moving along and just showing you the civil and environmental engineering course, which looks very, very similar. Those red subjects are all the same. The blue subjects are the same. The only differences are here is that you start to see the introduction of some environmental engineering subjects. For example, pollution control and waste management. Down here in block 1, water supply and wastewater engineering. You start to actually see over here in block 3, some more advanced subjects around environmental planning and law, renewable energy technology. So you basically are still doing the core civil engineering subjects, but on the periphery, you're actually doing some of these environmental engineering subjects, which give you a little bit of a different experience. Again, we actually have our 2 internship opportunities here, 24 credit points each one. And importantly here, you can see there's also an elective option where you can choose a postgraduate subject that actually gives you an advanced learning of some environmental engineering aspect. Everything else in this 5-year degree is exactly the same. So just moving along and just to sort of give you a little bit more of a reflection of what the importance is of doing those internships. It says here you'll complete 2 6-month internships, which are fantastic because on top of your bachelor degree, you also get a diploma. So in a sense, you're getting 2 qualifications in one, and that's called the professional engineering practice component. You get to work out in industry, and what's really unique about this opportunity is that a lot of students land themselves permanent jobs after their first internship. About 60 to 70% of those students actually start to work full-time and then do fewer subjects to complete their degree within a 5-year time frame, which is still achievable because you can also do some subjects over summer as well to catch up. And a lot of subjects are also in the evening as well to help those students. So you get to network with industry, you share your professional skills, your values with them, and they like it, and they'll recruit you as basically cadets and graduates. And most importantly, you can actually build further networks and you can move from one job to the other with top organisations within industry that are not only located within Australia, but internationally as well. So the sky's the limit. We also offer flexibility for you to actually combine your degrees, your engineering degrees, with other degrees from other faculties. So I was about to say double degrees. And so you can actually have an engineering degree that's combined with a Bachelor of Business, Arts in International Studies, Medical Science, Science, Creative Intelligence and Innovation, and Law. And this gives you the opportunity to actually finish 2 degrees in a short period of time. So over a 6-year period, for example, you can finish with these 2 degrees. And as I mentioned prior, if you've got an interest in patent law and innovation law and commercial law, you may well choose to do this combined option, which is very, very beneficial. So I'd like now to hand it over to Mihir to give you a little bit of insight in what it's like being a student at UTS and doing an engineering degree, particularly a civil engineering degree. Thanks, Mihir.
All right, thanks, Kirk. Hey guys, so just to start off with, since this is open day, I'm pretty sure a lot of you are wondering maybe what university to go to and maybe in general what course to do. So I just wanted to talk about my experience as a year 12 student. So I know this is open day and these are current circumstances, we can't actually come to building 11, but as a student in year 12, I remember when I came into building 11, into the open room and the basement in building 11, I remember the atmosphere, it just made me feel that I wanted to come there because there was a group of cohorts that just looked like they wanted to work hard, they wanted to study, and they wanted to gain practical experience that would help them be successful in the industry. And I just thought I wanted to be here among this group. And that was my experience in year 12. I think after I joined university at UTS, I've been feeling the same way ever since. In my first year, I think it was a bit challenging I came off from UTS InSearch, which is actually a pathway into UTS. And I found that UTS is a bit faster paced, but nonetheless, I found that UTS actually has so many support structures like UPass, which actually I'm a leader of, and which maybe we'll talk about a bit later. But I found that UTS actually gives a lot of help in making sure that you have that appropriate guidance and you have that extra help just to be successful in your studies, which I think is really necessary in a bachelor's in the life of a student. The other thing I wanted to talk about is the internships we have at UTS. I think it's really important because UTS gives you the opportunity to do 2 internships, which I think is a really big comparative advantage because you have a big practical experience before going off into the industry as a full-fledged engineer, which I think makes a big difference because you already kind of know what your specializations are. You kind of know what your strengths are. I started off as a structural engineer, as a student engineer working in a structural engineering firm. I worked as a designer and drafter. And in that, I found that I'm actually quite good at sitting in a table and chair and working for 8 hours straight in front of a computer, just drawing up, just doing drawings and just looking at technical stuff. But that's me. Some people might find that their strengths in construction, like Kirk said, which is more on the project management side and leadership and teamwork side. So in civil engineering, I found that there's a lot of different branches. It doesn't have to mean that if you want to be a civil engineer, I think one of the questions was that you have to be good at drawing. Not necessarily. There's a lot of different skills in civil engineering, like teamwork, leadership, problem solving, and there's a lot of different areas like Kirk mentioned, like water, geotechnics. So I think the scope we have as civil engineering students is quite broad. And I think that's one of the greatest prospects I kind of like about my degree. And yeah, I'm in my 4th year now, very close to my completion. If you have any other questions about what it's like actually being a civil engineer at UTS, a student at UTS, definitely feel free to ask me later on, guys. That's pretty much about it for me. Thanks so much.
Thank you, Mihir. Very much appreciate that. Thank you for sharing that feedback. So just moving along with the presentation and just some other information for you, which will be highly relevant considering we've got a large amount of year 11 and more particularly year 12 students here. So I saw one of the questions I was asked earlier, is there any requirement to have any prerequisite subjects? The simple answer to it is no. We actually have flexibility for you to actually come in without obviously any prerequisite subject knowledge. However, we do recommend that if you're looking to actually have that background knowledge, there is basically Maths Extension 1 and Advanced English that would help. Physics for all engineering courses and chemistry for most engineering courses, which is very helpful. But there's no actual requirement to have that. In fact, a lot of our students come from different backgrounds and they pick up very easily what it is they need to do in those subjects because they are quite introductory. And also there's no requirement to actually have basically engineering studies there as a requirement. So quite often we're asked questions around adjustment points, and this is just to give you a little bit more of an insight that the points are added to a student's ATAR to give obviously a selection rank. The adjustment points are capped at 13 at UTS, and the adjustment points can be given for a number of different factors, including the completion of the UTS engineering and IT questionnaire, good results in relevant HSC subjects, particularly around the year 12 subject scheme. There's adjustment points based on gender, and there's also some other special circumstances and more requirements that we look at and make obviously some particular judgment on whether or not adjustment points can be given in those particular instances. So I like to just sort of point you to that website down the bottom here, where there's some additional information on basically the adjustment points as such. So in terms of some student support services, the university is very strong on offering some bridging courses, particularly in the areas of maths, physics and chemistry, if they're needed. And there's also, as Mihir mentioned, UPass. And he mentioned that he's a leader, and the acronym stands for Peer Assisted Study Success. And it's available in some subjects, but also your peers that actually go on and do other subjects. It's often a good idea to chat to them as well, to get a little bit of a reflection of how their experience was to help you through with your studies as such as well. And one very important thing to remember is that engineering itself is a team-based workplace type profession. And so it's a really good idea to actually start creating some of these peer networks earlier on when you come into UTS. So I like to sort of just before handing it over to Bruce to wrap things up, I'd like to sort of give you some idea on how to make some connections, further connections for information at UTS. We've got obviously Facebook and Instagram links down below there, you see on the left here. And we've also got the email address. So if you've got any queries regarding today's sort of presentation, feel free to drop us a line. And we also have the engineering website, which you're quite welcome to log into to have a look at the different programs and some of the career opportunities and some of the other success stories that have been shared with students both locally and abroad.